Hey everyone. As we know, the modern hacking attacks are getting trickier and more impactful day by day. With the new DDoS, RC attacks, and also memory clogging attacks, we disrupt the privacy of the user. We disrupt the company's reputation, privacy, user privacy, security, trust, and data breach. These are all enough to disrupt a company's entire foundation. And many modern antiviruses, well, they can catch it, but the damage is already done. So as we can see, this isn't a older problem. We got a Log4Shell at 2021. We also got a Citus NetScaler, Wavery Technologies, and even a Microsoft Office where you can also uh, embed remote code executions in your document pipelines. That is RCE. RC stands for Remote Code Executions. An attacker can directly inject malicious code into a website server, which will be evaluated by the server and return a output which isn't intended to be shared. Well, these can be user data, these can be sensitive information or confidential information, these can be anything. And these pose a very serious issue in today's technological advanced state. Also got memory malware, where websites they don't directly inject malicious code, but they would inject malicious processes. What would these do is out of your entire memory, they would take a chunk of a memory constantly, clogging your memory bits into you, making your APIs and making your services clog and well not run well. So for this issues, me and my team introduced to you Aegix. Aegix is a kernel level monitoring system which stops malicious commands before they can even step into your system. So for our architecture, we have used eBPF based trace point, which would intercept your commands before they can be even launched for processing. We have also used a three-tier based system for evaluating whether a command is malicious, safe, or suspicious. We have a rule engine which takes in where pattern matching, keyword, reverse shell injection. We have these rules based on our algorithm. We trace these patterns and we calculate a score. We also have a ML scorer which does TF-IDF and logistic regression behind the scenes and also penalize them based on their score. We also have another newly added layer called the memory layer. The memory layer again checks for if a process is taking with a suppose PID X. Suppose the process got a PID X. If this process takes greater than 200 megabytes of a memory space in you, or even like 5% of your memory RAM, well, this is a very huge percentage at scale. So if a PID is taking this much space, this is automatically flagged and penalized by our algorithms for further verdict. And if a uh, total score of your classified command is under 30, well, it's considered safe. If it's under 30 to 69, it's considered suspicious. Well, this can be or this may not be uh, malware, but you need to be aware of it. And we also have a pretty good notification system letting you know what are the issues exact. And we also have a malicious score bracket which is 70 to 100. If this is between this, if your command is between this score bracket, it is most probably a very malicious code that should be stopped right and then and there. So for the logic of stopping it then and there, we also have a feature which I'll talk about it later. We also have webhook integrations and also a auto remediation. I was talking about this when we were talking about malicious code stopping then and there. I'll explain to you this in more detail in a bit. We also have a local persistent storage with SQLite. And by me, by the word, I mean local storage. I mean we are not storing any of your data here. Everything is stored in your own system. It is calculated in your own system. Only the backend and handled by us and nothing else. Every bit of we value the user's privacy and also the business privacy. So we would never ever store your data. It is all in a system and nothing on our side. As for the event flow, well, we have suppose the user is working on a terminal or there's a server running up on let's say a Linux machine. Well, again, in a Linux server, you evaluate and execute hundreds of lines of code. So how can you know if the command you're executing is it even safe or not? So we got an eBPF system which well sits on a monitor, which sits on a kernel level. Okay, as you know, kernel level is the lowest most stage of a computer. It has all the access to every process and everything. Yes, we are fighting at a very sensitive scale, but due to the security reasons, we have to be situated at the kernel level. And yes, I guarantee you it's totally safe. We have tried and tested it a lot. So a eBPF monitor sits on a kernel, and whenever a command is run or whenever a command is written and press enter, our model instantly executes it. We have a rule we and execute the rule based matchmaking and also the ML scorer, and quickly gives you the verdict in a JSON format with the risk score and if it's safe or not. And if we have auto remediation off, okay, auto remediation is nothing but an eBPF sub integration, which if a process is flagged as malicious, it would then and there stop it. It won't proceed further and it won't execute it at all. Well, on paper, this look good, but does it actually work? So yeah, here's our demo. I present to you Aegix Security. Me and my team have handpicked each of the features that usually takes in by the company, and we have also kept in mind about all the various features and also all the various uh, programs that you might use. So here, this is our basic front end that we have built. Well, as you can see, there are a lot of numbers and a lot of ports. Well, let me explain to you it bit by bit. First, we have a threat monitor overview. Here you can see all the numerical quantified data that we have done till now. Among all the tests, we have 19 active threads, 7 block tests, 8 safe commands, and total scans of 27 commands. This all data is stored in SQLite databases locally in our own system so that it does nothing comes to us. It all the data, all the calculations are on your system locally with full security. Now, let's give it a try. So I have set this Postman collection with various different commands. Like as you can see here, this is our command. This is the command. These are all the commands that we are testing. Now you may ask me, why are you using a Postman collection rather than not showing it on kernel? Actually, Windows and Mac OS doesn't actually allow you to get a kernel level access of a system, but Linux system does. We currently don't have a Linux system, so I'm simulating a Linux system via posting it directly to a backend. But I assure you, this works exactly the same with the actively monitoring kernel level in Linux too. So first, let's run our save command. Let's see, like ls that ls. This is going to just list the logs. There can't be nothing suspicious about it. So let's run it. As you can see, this our backend returns you a JSON file, JSON command that is classification. It's safe. First, this is the risk score of 8.9. It the ML confidence is 0.7. So the command is appears safe and it has a risk score of 8.9, and no suspicious patterns are detected in this command, and the model confidence is 77.7%. Well, it is pretty tedious to look at a JSON every time you're running a command. So hence we built a front end out of it. As you can see, I haven't refreshed the page. The front end actively check for its updates at regular intervals without clogging a memory. And we actually updated. As you can see here, the time, it's PID, it's what was the command, what was the list, and also uh, what is severity. We also have memory and RAM percentage. Well, again, Windows doesn't allow us to see all those numbers, but Linux system does. We also have a simulated system test, as we'll see further in our demos. So yeah, let's continue. So this was a pretty safe. So this posed no issue to us. As you can see, we are bashing into a URL. So let's test it out. Yep. This is a suspicious command. As you can see, it is automatically updated in our system. And this gives you the severity score, the risk score, the confidence, and everything. We also have a trigger tools section which tells you what rules it did actually break in order to get this score. Now let's move on to download and execute. Well, this is a pretty malicious command as you can't let a server download anything on the internet. So yes, this is also flagged as a critical issue with a score of 80.2 with a critical severity, and this is top. Now, you may ask us key, how would that auto remediation stop it actually? So let's see it in action. Suppose, yeah, let's check another one like memory spike. As I was telling you about the memory spike, as you can see, the memory has exceeded its percentage and the RAM percentage, so it is flagged as suspicious. and also has a critical memory usage. So the user can get a notification on this saying, "Ki, please check it out," and just cross it. Because as you can see, this is not so malicious at the first look, but it takes a memory and may entirely disrupt a system. Now you may ask, looking at this list is pretty tedious. So we have also implemented a webhook integration platform, which, well, you can have multiple triggers on. Suppose I want suspicious and malicious commands for me to get a notification. As we know, companies have multiple departments issuing tickets and tokens for these issue and logs. So we have integrated a webhook system where you can integrate either your any webhook server like Discord, Slack, and anywhere that you're working on. You can just add in your URL link and just add a webhook. So whenever if I see a command that is suspicious or trigger or malicious, suppose I run it here, it is updated as usual, and I also get a notification. I also get a notification pushed here with this process PID with a git score and also a command. So that tickets can be generated and proper investigation can be done on this command too. Now suppose we also have a malicious command. Yeah, let's see for the malicious command. As you can see, this is a malicious command. It uses some memory, it uses some RAM, and it is also very critical. And the notification is also updated at the real time. Now let's enable the auto remediation for now. As you can see, the auto remediation is on from here. And let's test something like this. Yeah. So at a Linux standpoint, remediation on what will it do before it, because we are just posting it to the API, right? We are not actually running it. So when you're running it, remediation on will actually kill your process and stop it then and there at instantly. So this is how our entire system works. For the configuration, again we have a dark mode and a light mode according to your preferences. We also have a AI sensitivity slider. As you can read it here, it controls the strictness of the heuristic engine. The higher the sensitivity, lower the required score required. Like suppose I crank it up to 90. So any score above, suppose I crank it up to like 80, let's say. So now most of the commands that will get a score of up to 80% will also be flagged as malicious and won't pass through your system. And if I keep it way lower, well, it will bypass technically all of them. It won't like predict or it won't uh, act as a safeguard on the system. So for our testing optimum, we are keeping at 40% according to this threshold range, as you can see. So standard 30 to 40% is fine for product environment and balancing robust security and normal system operations. And for well maintenance feature, we have also feature of export logs, well, which you can download it straight with just a click, and you will have an entire JSON of all the commands that have been run till now, and you can make logs out of it or use it as anything. This is totally your own data up to your own server. So this is how our entire project works. This is our architects, and this is Team Aegix. Thank you.